Everything test here still looks good. We'll get almost done. Finish it up here. Practical here. Practical will raise your grade unless your grade is 100. It won't say where it is from. So unless you just fail to study. But as you're studying for the test, you're studying for the practical. The images are online. That's pretty much what it looks like. A few surprises, but not many. Okay, 20 is today. I said we're going to finish this one pretty quick, right? And we're going to get into this guy, 21. Yeah, I did. So let's do 20. It should take about 12 minutes, but I'll put down that where it takes about 45. That's still going to annoy me because it's a silly chapter. Every year I just want to tell people, just go read it and you'll figure it out. So let me go and hit the highlights here of chapter 20. So I'm going to do. I'll tell you how all the Aspen stuff, pretty much just as straightforward as it gets. I mean, it's a very easy chapter. So know the vocabulary words, make some flashcards. The anatomy is super simple. Pay attention today. You'll probably have chapter 20 studied just by being conscious. So here we go. And we did all of 19, didn't we? I hope so. 19 used to have twice as many slides. Alright, here we go. Second easiest chapter of the class. I've done most of it already when I drew our little capillary bed doodad. I might draw that again. Artery, venule, arterial venule going across. Okay. Oh, HP bigger than OP on this side, OP bigger than HP on that side. Okay, same picture. We're just in the green stuff now. In fact, that kind of looks like the image we drew last time, but a lot fancier because they got paid more than we did to draw it. So there's a capillary bed that's got the flow going this way for some reason. I don't know why they flip it around so much. It's good that they do, but it confuses people. Green fingers intertwining into the red and blue fingers of the actual capillary bed. So lymphatic capillaries, blood capillaries. Okay, it's all the same tiny little tubes. Yeah, they do have flap-like mini valves, but it's the stupidest name. So they are going to suck up fluid through these little valves. It's a one-way thing, and it's not that important, but that's what's happening there. So the excess, exudate, stuff that doesn't get cleaned up by other mechanisms, gets cleaned up this way, vacuum it in these little tubes. The little tubes merge with larger tubes, and so on and so on. So we generally call all of it together just, those are the lymphatics. All the lymph, which remember is, I'm just going to put a silly word, it's the juice inside. It's not called blood, you can't call it stuff, can't call it juice, so lymph is the juice inside. Once it's not exudate, once you vacuum it up, it's called lymph. And we talked about the nodes too. The only thing we need to add here is and spleen, because it gets thrown in here as an extra, because it kind of is. I could describe it as a lymph node gone wild. It's going to be like a lymph node that has this extra function and it's gigantic. So when you think about what a spleen is, just say it's a big giant lymph node plus something extra with it. Return leaked out fluid, it's calling it interstitial fluid. I can call it whatever I want to call it, like exudate. Once interstitial fluid enters lymphatics, it's called lymph. Got it. You probably know, since we're going to see some lymphocytes, right? Give me the two big players. E and T. Remember all this because it's coming back today. Wait, not B and C cells. B and T cells. Yeah, remember their friends NKs, but they're always a side story. And of course, we know this is about immunity, which is the next section, so we should see them play a role. So lymphatics, lymphoid, lymphocytes. I mean, the key term here is lymph. It's all about cleaning up messes, literally cleaning up the mess, and then smashing any nasty that's inside, like bacteria, fungus, viruses, and then returning it to the heart at some point. So one-way system toward the heart. Just like veins, I'm going to say that multiple times because you're going to see these vessels are just like veins, pretty much. To us, they're going to be indistinguishable, except they'll be green on pictures. We won't have pictures though. There are little tiny capillaries. We saw those fingers interwoven. There's bigger vessels, but Those are never interesting. There's larger trunks. Those are never interesting. There's two quack ducts. One's called the right. Remember this weird thing? Lymphatic duct. What was the other one? Yeah, the weird thoracic. I did look up. I did get it right, but it's weird like that. That's all you really need to. I mean, that's the anatomy you need: is lymph node anatomy, some spleen anatomy, and then the two ducts, and you're done with lymphatics. It's very, very simple. You can get in and learn every piece as part of a lymph node if you want to, but I don't see the purpose of learning every little piece as part. We'll learn the pieces we need to learn. So that's our tour. There it is, halfway done. Blah 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 blah. I would just do this like teal. You'll see it later. It'll be more important later, but right now we know they are intestinal lymphatics. That's where they are. It's a very terrible definition of what they are. If you know what a villus is, you don't have to yet, but if you know what that is, I'm just going to show you. I will do this better later. In the stomach or so forth, you have these blood tubes going up and down. You'll also, in the same villi, see green tubes intermixed with them. So if you see these big lumps, they're often just called villi. Sometimes two L's, depending on what book you're reading. These huge fingers sticking up out of the top. You may have learned they have little things on top called microvilli. We're going to do all this later. You just need to know that those green things are called lacteals. I only find them in intestines. So for this test, lacteals are intestinal lymphatics. That's all you need. Later we'll see them, but they're going to look like that. They're going to be inside these large lumps that come out of the digestive system tract. But we're not there yet. So lacteal is a lymph structure. Okay, yeah, look at all the wonderful flashlight mini valves. Okay, hey, they're similar to veins. I think I just said that. Except they're thinner, even still. I don't know how that could come up on a question, but they are. And there are more valves. Remember, there's no pump at all in the lymphatic system. There's no heart, ever. So, anastomose, what's that word mean? Yeah, they bypass, shunt, form different. Yeah, who cares? They do that. They shunt around more frequently, but so what? More than veins do. But so what? We didn't really talk about that too much. Two large quack ducts, what are they called? Lymphatic and thoracic. Been there, done that. You can learn where it drains from here, drains from there. I'll never try to trick you. I mean, there's where you drain. And if you have your sketch last time of the veins, we should have drawn two green tubes. And we should have done that at the junction of the internal jugular and the subclavian. If you have that picture handy, just look back at it real quick and you'll see those two tubes coming in, and we should have drawn those two little tiny green arrows right at that junction. So if you have it, check it out. I'm telling you it's true. This picture, you can't see anything that they're trying to tell you. That is the dumbest picture I've ever seen trying to show those ducts. So check it out. You drew the green tubes in at that junction. I'm definitely going to ask you that. It's underlined, for God's sake. So very few things I'm going to ask about lymphatics. That's guaranteed. I'm going to ask about the two large ducts. So know their names. A lot of people put left and right. It's right and thoracic. And then where they plug into the venous system. That's where it's at. Okay, I would definitely ask all of that at some point. Just underlined in box. Okay, this is kind of showing a couple things. It's not showing those ducts very well at all, so don't worry about it. In fact, it's labeled way down here. What you need to notice are these groups of nodes. Inguinal in the upper inner thigh, and the inguinum. Axillary in the armpit, cervicals in the neck. The point is we don't have them everywhere. So I'll give you the word again that you see. You'll probably see it. Maybe. Oh, that's bad. That was close. Strategic. Is that how to spell strategic? It's bizarre to me. It's like Russian for some reason. Strategic. These are the strategic locations, right? And remember, this is the main part of your body, is the trunk, right? That's the main part. All that extra is just extra. Like if you go way back to animals in their primitive form, that's all the sponge is just the body. Since then, there've been some changes where you get this head, these appendages stick out and so forth. Well, if that's the main part, and you want to protect that, where are you going to put the military base? So I'm going to put it here, and here, and here, and here, and here, and here, right? Makes sense. You protect how you get into the trunk. So we don't have, like I said, tiny West Texas towns don't have giant military bases. You don't need them there. Put them in strategic places. There you go. That's all that's showing. It's three main groups: cervical, axillary, inguinal. I think you know the roots, but there they are. That's the only thing you need to get off that picture. You don't need to see anything else except there's clusters, and I kind of missed down here, but there's clusters of nodes, not everywhere spread out in the body. They're localized. Okay, it'll say that somewhere. How do we move venous blood? Well, same way we move lymph, same way we move venous blood. Arteries push it, twitching around, some of the walls. Same way venous blood's moved is the answer. You move lymph just like venous blood. There's no pump, so you have to either breathe or fidget around or have the peristalsis thing going on. I mean, these do peristalsis as well. We just don't touch on this much at all. Just think of these being little veins, and if you've studied veins, most of this makes sense. Which one are we missing here? The NKs, right? We'll talk about them. Yeah, our lymphocytes, don't forget that. But it says the main warriors here are the T's and the B's. So, yeah, okay. We're going to see some more on this today, quite a bit. Actually, we'll wait till next time to see their story all the way. Okay? Yeah, blah, blah, blah. Blah, 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 blah. We'll get to that later. That's nothing. You see the word antigen? You've seen it before, right? You learned it as an ID tag or something like that. I'm going to put it as AG when I write it. Just think of it as the bad guy from now on. To say, okay, the antigen is the foreign thing. We're going to start there. I think it's silver. Not silver here. So antigen AG. That's the bad guy, the foreign guy. It's going to trigger something. But we're going to call it that for now. We'll give it a better definition later. But you can see that first word of their definition, anything. I mean, that could be a lot of stuff. So we'll hone that in better, probably a week from now. Something like that. Okay, no, actually, let's go T cells. Okay, T cells, managers, right? Snitches. Remember, I'm just trying to get you to remember, what was the word for this response? We called it cell mediation, remember this? Yeah, that's what this next chapter is about again. But all the details of it. We just learned the words really last time. We didn't really see it happen. So yeah, they do attack. Some of them do. Some. TC cells. See, there's multiple T's. Who's the managers? TH, right? Helper T's. I'm sure you've heard of that somewhere. Helper T's. They manage. TCs are killers. They get snuck in there at the end. They don't snitch. They'll just stab you. So B cells, of course, secrete antibodies. We usually draw them as Y-shaped proteins. We'll see all the details on how to build one of those when we get there. What's that called? Not cell mediation, but humoral response. Yep, that's what this Tuesday's talk will be about these guys in a lot of detail. Just trying to get you to remember it. Nothing really new there at all, except maybe TH and TC. We'll definitely do that better when we get there. There are macrophages down here too. We'll see them when we get there. Macrophages doing what macrophages always do. They eat big. I mean, it tells you in their name what they do. My friend's coming over. He's a big eater. You can picture him already, right? It's not some skinny little dude. So you know what he's coming to do. He's coming to eat. I don't care about that at all. It's interesting, but we can't talk about everything that's interesting. Do what the state says, and then we go home. Okay, nodes, got them. Inguinal, near the thigh, right? Axillary, armpit, cervical, up in the neck. Not everywhere, strategically located. It says here in clusters. Yeah, strategic locations. Cover the trunk. All the exits and incoming from the trunk, especially the incoming. That's it, principle there. We're done with the anatomy, pretty much. Silly picture twice, it should be erased. It's the same thing. Nothing important except remember we got 3 sets, cervical, axillary, inguinal. We're protecting the trunk of the body. You don't need them all up and down the arm and in the fingers and top of the head. Strategic. Okay. We know that this is gonna have something to do with immunology. B cells, T cells, okay, fine. And filter length, clean. Clean. Yeah, we know this. That's what they're gonna do. They're gonna pick up crud and clean it up. Some of this is called immunity. They're gonna do it via immunity. But there's macrophages doing it the old-fashioned way too. This is just a repetition. Let's look at the hard part. This is the hard part here. So, capsule, trabeculae, cortex, medulla, and then some other things coming. There's the main words. And you can actually draw one of these pretty easy if you want. You want it? No, it's not. Let's just look at that one because it's pretty good. So this next slide has some more. I'll get to that in a minute. We already know what cortex and medulla is, correct? I'm going to draw a little lymph node, kind of looks like a bean, like a whole bunch of stuff does. Where's the cortex? Where?
The outside.
On the outside, right? Medulla's in the middle, right?
Mm-hmm.
So we're going to see that divided up like a whole lot of things, almost like a fruit is divided. There's an outside part and the inside part, the rind and the peel on the watermelon, whatever, cortex and medulla. We'll see the same thing here. I probably won't ever ask you to spot the cortex medulla. Just remember the terms. There's a cortex and a medulla. Okay, cortex on the outside. So look here. So here's a capsule. We'll start on the outside, the green thing. All the green thing. Most organs have a capsule around it. That's not that important, but it is there. Capsule, protection. Okay, fine. It says what the capsule does here somewhere. No, it doesn't. Protection. All right. Follow the capsule and you'll see. I'm just going to outline them. You see these little beams come down. We've heard the word for beams already. I heard the meat beams, but these are just normal beams. So the trabeculae, again, beams. It always means that every time you see it. The beams don't go all the way to the bottom. I mean, all the way to the middle, I should say. Notice there's I'm trying to do this. It's like a middle part here, right? I'm going to put it up top, medulla. So I'm going to write something there in a minute. But there's the middle. Those beams don't go all the way to the middle. The trabeculae are out here in the cortex. And they're compartmentalizing the cortex. Putting it into compartments. Right? Does it say that somewhere? No. That's the word I use for it. Compartmentalize. They're putting them in little rooms. So just one giant room. Compartmentalize the organ. So that's what the trabeculae are doing. That's all they're doing really, is putting them into little sections. Inside of all those little rooms, since we built a wall in between all those little rooms there, something going on inside here. I can see this color. There's one. There's a little lump of something happening in here. Inside of those little rooms. Okay, so the trabeculae is just the wall separating each little room from each other. And I'll just go this up here. Germinal center is what we call each of those little blobs. Those are called germinal centers. So out in the cortex, divided by trabeculae, are the germinal centers. Okay, I'm just using the words, and it says right here, cortex contains germinal centers filled with B cells. So go in here and just write B. That'll remind you. B cells out here in the cortex doing their B cell thing, which is humoral response, which is make antibodies. Being very generic here, but that's what to think of. Out there in the cortex, you have these walls called trabeculae separating these germinal centers into their own little rooms. Inside the germinal centers are a bunch of B cells doing their thing. Making antibodies. Okay? I would kind of skip this because it gets a little weedy. Okay? Then it says inside. What do we see? B cells, T cells, and macros. So I can go back now and kind of cheat a little bit here and say in the medulla. And there are some gray areas here, but I'm going to make them simple. There's B cells. No, not that. There's B's and T's. Oops, that's a good J. And T's and probably NK's. We're avoiding them. And macrophages. Everybody's active down there in the medulla. That's why I remember this little thing. There's a couple little more pieces. You can see the tubes. I'll get them in a minute. But that's it. That's as hard as it gets right there. Just super simple. So we've got this cortical area separated by trabeculae, the little rooms. Inside of each of the rooms is B cells. All the little rooms, germinal centers. In the medulla we have B cells, T cells, macrophages. Doing their B cell, T cell, macrophage things. We'll learn about more. Okay, there's some tubes coming in and out. You're probably familiar with the word afferent and efferent already, right? Just remember E for exit. It usually works most of the time. How many afferents compared to efferents? More, right? Way more afferent. Remember on the test, the little arrows won't be there showing you the direction. There will be a picture of one of these on the test, by the way. So it'll be super simple, but there will be an image of a lymph node on the test. I think on the practical also. The arrows won't be there though. You'll have to remember that there's just more going in than there are coming out. Why would that be? Yeah, so if you have there's a theater, there's all these doors to get in, there's only 2 doors to get out, and there's a fire, what happens? Everyone's dead, right? It's called a fire trap. That's why you can't have 5 doors coming in and 2 doors going out. You can't have that. It's against the law because of that. But remember, what's the point of this lymph node? You want people to come in, meaning bad guys, bacteria, viruses, dead cells, crud. You want the crud to come in and stay a while, right? Why do you want them to stay a while? So you can keep beating them up, right? Beat them up. The ones that manage to get out, what's waiting for them right down the road? Another one, right? And they're gonna go in and then like, oh no, I'm trapped again. And beat, and then eventually they'll be ripped apart. And when we talked about, well, let's not do that yet. I'll say that story. Okay, so more afferents than efferents, more coming in than going out. It's gonna slow down the flow. It's gonna say that in a second. It's gonna make sense. That's it. There's nothing, I can repeat it, but that's it. I don't think that's gonna ruin your grade on the test. This is the easiest part. Know the terms, of course, but don't stress. Hilum's always the pocket. Anytime you see a pocket of an organ, it's called a hilum. There's a lot of tubes that plug in and out of a hilum. Sometimes it's called a hilus. I usually don't talk about the term because it's a very generic word for a little pocket. But hey, efferents are in the pocket. I just remember there's fewer of them, so that's got to be the efferents. That's the major mistake on that picture, by the way, is missing afferent for efferent. Everything else is pretty simple. Okay, this is a little much. There's a little gray area on the side. Here clarifies it. B is out all alone in the cortex. B's, T's, and macrophages in the medulla. Don't worry about the cords and the sinuses. I'm not going to get that detail. Okay, there you go. That picture right there with the drawing should do it. Okay, enters afferent, exits at the hilum through the efferents. Fewer ways out than coming in, causing stagnation, allowing lymphocytes, remember B and T, and macrophages to carry out their function as in kill, murder, destroy. Okay, there you go. Now you know the lymphatic story. It's not much more. Okay, spleen, I said lymph node gone wild, basically. I did sneak this in here. All I did was Google spleen anatomy image, and that came up. So you can find these anywhere, but there was not a picture of a spleen. You don't need this picture for anything, but it is good to see this, because I do have some problems on this part. So let's talk about spleen real quick. First of all, this is different. The lymph nodes, let's go back. Where's the blood supply here? There's not. Remember, this is a lymphatic system. Those lymphatic tubes have cleaned up the stuff and they brought it to the lymph nodes. There's no blood coming in here, right? Like we talked about. There's no blood. There's no big lymph node artery, lymph node vein. It's even weird to say that. But this guy, the spleen has one. That's big time different. And the picture shows that there is its own artery and vein. We saw it as part of, remember this thing from last time, sort of? Let's see if we do. What was this thing called? The branch was called what? Celiac. And this went G, H, S, and then P came off here at a weird angle. What's the S one for? Splenic, right? This is the splenic artery. There's also a splenic vein we'll see later when we need to. But the point is, there's a blood supply in and out. The lymph nodes do not have that. So this is going to give it another different, totally different function. So that's a big deal. It's got its own blood supply. Lymph nodes do not. So when we look at, well, what does the spleen do? Well, lymphocytes do their stuff. Well, that sounds like a lymph node to me. Yeah, the spleen is a lymph node. It does what a lymph node does. That's the lymph node part. The lymphocytes beat up stuff. They do immunity. They do cell mediation and blah, blah, blah. They do all that stuff. This is called white pulp. You don't have it in a lymph node because the lymph node is all white pulp. This is the lymph node part of the spleen, is the white pulp. It does the same thing that a lymph node does. And that shows it there, even though you don't have to really see it. But you see that blob of white in there? That's the lymph node part of a spleen. But there's all that red stuff too, called red pulp. And I'll just write it here. When we learned our essay about what happens to a red cell when it dies, we said something about they wear themselves out banging through capillaries. Eventually they make their way to the liver and spleen, right? Spleen and liver, where they're broken down. That's what we're doing here. So the red pulp is dealing with blood. That's the part the lymph nodes can't do, because lymph nodes don't have a blood supply. They don't have red pulp. So a spleen is kind of like half of a lymph node. That's the white pulp start, normal lymph node stuff. But that red pulp is different. That does what we think of spleen's doing, breaking down red cells, and some other things we'll see too. We'll get more specific when we talk about it in another sense. But there's white pulp, red pulp story. People miss that a lot. That's why I'm saying it. I don't know why they miss it a lot, because it seems very easy to me. So spleen is different from a lymph node because it's got its own blood supply. This gives it two functions. White pulp function is just like a lymph node. Red pulp function is something different, filtering blood. Not like a kidney, looking for broken cells. Okay, and then, okay, let's do this at the bottom, maybe. Nope, let's not do any of it. Okay. So remember, the picture is not important to me. It's right there, white pulp, red pulp. Okay, there's the white pulp, red pulp in the notes. Again, white pulp's the lympho part, red pulp's the blood part. The thymus gland, again, we've seen it, but several of you confuse it with thyroid still. I've got a picture of it here so you can see it. Where was thyroid gland? It's up in yonder, right? So we're talking between the, down where the heart is, sort of in the mediastinum, mediastinum, some people call it. That's where the thymus is, so get a good look. That's the one that gets smaller as you get older, right? And it says that here. Stops growing during adolescence and then gradually atrophies, stops growing totally, may even shrivel up. And that tells you it's got something to do with immunity, and that's why I say most active during childhood. And then as you get older and your immune system is established, it becomes essentially useless. So just remember where it is, mediastinal area. You forgot the word. A lot of people, again, mistake this for the thyroid. What we're going to find out is T cells mature here. I don't know why I didn't say that. T cells mature here. That's why they're called T cells, because of the thymal cells. So that's going to be helpful in the next chapter. Because this chapter is not very helpful at all. Okay. Tonsils, what do you need to know? Because we're not going to learn them. You need to know that tonsils are lymphatic tissue. They're not digestive structures. Yeah, there's some up in the mouth and in the throat, but they're not for digestion. They're for protection. They're for lymphatic. So there's the main thing. When you see the word tonsil anywhere, immediately tell yourself that's a lymphatic structure. And that's what you need to know. You can go name them if you want, but I don't want them. So know that a tonsil is a lymphatic tissue. That's it. Know that there's things called Peyer's patches. that are also found in the intestine. Intestinal lymphatics, but don't confuse it with black teal. So here's the way I'll show you that. Small intestine, and it says it right there. Shouldn't have even needed to do that. The small intestine is broken into 3 parts. I know we haven't got here yet, but there's a lot of crossover. The duodenum, we've seen that guy. Who's an expert, anybody know? What's the J? You need a name for your next 3 kids. Here you go. Duodenum, jejunum, and ileum. The love of my life. Notice how ileum is spelled. If you spell it I-L-I-U-M, you would spell it hip bone. Ileum. That's a totally different, very wrong way to spell ileum. So some spelling does matter a lot. That's one of them. The terminal portion. What do I mean by terminal? This is the most asked question I get in this class, believe it or not. What does terminal mean? What does terminal mean? The end. Yeah, I know, it sounds silly. I want to make sure we come out of this class knowing what terminal means. The terminal portion of the small intestine is called the ileum. That's where we find Peyer's patches. Not in the intestines. In the terminal portion of the intestines, in the ileum only. You don't find them in the duodenum or the jejunum. In fact, later that's going to be a landmark, so if you see them, if you see the Peyer's patches, you say, I know I'm in the ileum here. So okay, so more intestinal lymphatics will be more important later, but they're found in the small intestine, specifically the last part known as the ileum. And who cares about the picture? I'll show you much better pictures of that later. That's probably totally irrelevant. I can see them in there, they look like little triangle things, but so what? Okay, the state tells me I must inform you about mucosa-associated lymphatic tissue, which is small lymphoid tissue in the mucosa of GI, thyroid, breast, lung, eye, salivary glands. Now that I've informed you of it, you may forget it. Okay. They told me to inform you of it. Check, 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 Mr. State. Okay, that's all that crappy chat. How long did that take? Way too long. All right, let's do this first half here. This one's